Here's something wild. The same carboxylic acid that smells sharp can become a sweet-smelling ester with the right partner and conditions. In this video, you'll learn the big idea behind carboxylic acid reactivity and how to make acid chlorides, anhydrides, esters, including Fischer esterification, amides, and primary alcohols. We'll also note when each route works best. First, the why. The carbonyl carbon is electrophilic, but hydroxyl group is a poor leaving group. So, we need to activate that hydroxyl group to make acid chlorides or anhydrides, or change the reaction partner under the right conditions to form esters or amides. With thionyl chloride, the hydroxyl first converts into a chlorosulfite. Then, chloride ion steps in and displaces it, forming the acid chloride. Here's a bonus tip. Sulfur dioxide and hydrogen chloride gas are released, which drive the reaction forward, but also make it essential to work in a fume hood. The result? You've just set up a much stronger acyl donor. On the other hand, two carboxylic acids can condense under strong heat to make an acid anhydride and water. With acetic acid, high temperature can drive formation of acetic anhydride. In day-to-day synthesis, though, many anhydrides are made more easily from an acid chloride. We'll see that route next. If your target is an ester instead, there's a faster move. That is to deprotonate the carboxylic acid to a carboxylate, then do bimolecular nucleophilic substitution or SN2 on a good primary alkyl halide. That swaps halide for the carboxylate, giving an ester. But there's one catch. Watch your substrate. This SN2 pathway doesn't work well with secondary or tertiary halides because elimination takes over, or a clean alkylation, stick with primary alkyl halides. So far, we've covered why we replace or activate the hydroxyl group, how thionyl chloride makes acid chlorides, how heating can form anhydrides, and how carboxylates make esters by SN2 mechanism with primary halides. Want to turn those milestones into mastery? Tap the link to access the practice test, flashcards, and study guide, then jump right back into the video. Lock in what you learned and keep going. Now let's see the classic, Fischer. Fischer esterification is acid-catalyzed and reversible. Protonate the carbonyl, let the alcohol attack, then after proton transfers, water leaves to give the ester. Use excess alcohol or remove water to push toward ester. Excess water drives it back. Le Chatelier in action. To make amides, couple the carboxylic acid with an amine using DCC or dicyclohexyl carbodiamide. The reagent activates the acid, letting the amine form the amide bond. A key step for peptide synthesis in the lab. Then, let's take the reduction all the way to the end. Strong hydride reagents reduce carboxylic acids to primary alcohols. Lithium aluminum hydride does the job. Just remember it needs a separate aqueous workup. Borane in tetrahydrofuran is another excellent choice, and it's often selective for carboxylic acids, even when other carbonyls are around. Let's systematize. 1. Pick the target. Acid chloride, anhydride, ester, amide, or alcohol. 2. Match the reagent set, thionyl chloride, heat or another acid, alcohol with acid, primary halide with base, amine with DCC or hydride. 3. Mark reversible steps, like Fischer, versus one-way reductions. 4. Set a driving force and plan the workup. A few quick saves before you scale. Acid chlorides are moisture sensitive, so keep them dry. Sodium borohydride is too mild for carboxylic acids. Fischer esterification needs Le Chatelier help. Use excess alcohol or remove water. And carboxylate SN2 prefers primary halides, not bulky or secondary. Zooming out, carboxylic acids transform by activation, partner swap or reduction. Remember, Le Chatelier drives the Fischer esterification since it's reversible. SN2 alkylations work best with primary halides. And for acid chlorides, thionyl chloride is your go-to. That's the key takeaway for today. Ready to quiz yourself with the content covered in this video? Check out the link in the description where you'll find Quizlet content made just for you.